All right, all right. So the last time we hung out, we talked about VLAN management, and now I'm going to share with you some pretty cool concepts. You're going to learn about flood guard, you're going to learn about loop protection, and also log analysis. So before we jump right in, I just want to ask a question. Let's say that you were, I don't know, wandering around your organization. You happen to stumble into the data center, and you fall into the wiring closet, and you notice there's a switch there. There's multiple switches. Let's say you've got an Ethernet cable in your hand, and you plug one end of the Ethernet cable into an unused switch port, and you plug the other end of the Ethernet cable into an adjacent unused switch port. What would happen to the switch? That's the question. Well, consider this other possibility. Let's say you walk into a conference center, and you have an extra long Ethernet cable with you, and you just connect two Ethernet wall jacks together with that cable. What would happen? Well, either one of two things would happen. Either A, the switch would blow up, and which would result in a fire. Or B, your whole career would blow up because your boss would walk into the office, kick you out, which would result in you being fired. So in either case, there would be fire involved. And the whole purpose of this is to let you know what happens when you have loops on your network. So a switching loop, a layer 2 loop, is when you have a switch that is continually forwarding a unicast frame throughout the switch. And what happens is it denies access to legitimate clients on the network. So it's a great way to DOS, that is denial of service, your network if you do that. Now, fortunately, most switches come with built-in loop protection algorithms in place. So, for example, there is the spanning tree protocol, STP. There's the rapid spanning tree protocol, RSTP. And both of these, STP and RSTP, are enabled by default. And therefore, almost every organization that's using a switch is protected from this kind of attack. But you still need to know about it for the exam. The second thing that's really important is flood guard. Now, when I talk about flood guard, I'm talking about protecting a switch or a device from a SYN Flood attack. And usually this protection resides in a UTM, a Unified Threat Management Appliance. It might reside in a firewall. It might even reside in an IDS or IPS on your network. And if you're not sure what the IDS and an IPS is, go back to my previous video because we talk about that. But what happens? Well, you know what? Before we talk about that, I need to really take a step back. literally take a step back and explain to you what happens in a TCP three-way handshake. Because if you don't understand that, a SYN Flood is not going to make sense to you. So in everyday normal communication, a client wants to initiate a connection with a server. Let's say you're trying to communicate with Google. The client's going to send what's known as a synchronization packet, a SYN packet, to the server. The server's going to respond with a synchronization acknowledgement packet, which is also known as a SYN-ACK. And this is just the server saying, okay, let's go ahead and do this. And then a client responds with an ACK, an acknowledgement. At that point, both the client and the server can exchange data effortlessly, and communication occurs. Everyone is happy. In a SYN Flood attack, you have a single source IP establishing multiple connections, but they're half-open connections. So the attacker will send a SYN packet, but the attacker will not follow it up with an acknowledgement. And so the server's kind of caught in limbo, right? He's got all of these synchronization packets, these half-open connections, but there's no real data being transmitted. And so resources are allocated for this connection. RAM, CPU usage, and each half-open connection is just more allocation of memory until eventually the server either crashes or the system is no longer able to service legitimate requests because it basically is out of operation at that time. Resources are exhausted. So think about it like this. Let's say we walk into a room, and I've got it's my first time meeting you, and I say, hey, my name is Vonnie. It's pleased to meet you, and I extend my hand, and you extend your hand. But before I shake your hand, I grow another hand, and I say, hey, it's Vonnie. I'm pleased to meet you, and so you then try to use your other hand to shake that hand, and before you can shake that hand, I grow another hand. And I say, hey, it's Vonnie. Pleased to meet you, and I just keep doing this. You never get a chance to grab my hand. That's what happens with a SYN Flood attack. The connection is never established and resources are exhausted until the server crashes or just mayhem occurs. Now, traditionally, one of the ways to block this is, or to prevent it, was just to block the source IP. But attackers are getting smart. They can spoof the source IP, which means they can pretend, they can lie about their source IP. They have a fake IP. That's what I mean by spoof. Or they can compromise legitimate hosts and then launch this SYN Flood attack from multiple directions, right? So you've got all these legitimate hosts on the network. Maybe they've been compromised with malware. They're part of a botnet, and they're all firing these SYN Flood attacks against your device until it dies. So some server software will actually use a dynamic timing algorithm where after the SYN packet is sent to the server and the server responds with a SYN ACK, the server kicks off a timer. Let's say it's for 60 seconds. If within that 60-second window it gets another SYN packet, it's going to know something's weird because it should have got an ACK, right? So it'll scale that window down from 60 seconds to 30 seconds so that when the SYN packet does come, which is part of that SYN Flood attack, the server doesn't crash because it times out the connection a lot faster. And so this is one way of dealing with it. Now, one of the ways that we can monitor this goes into log analysis, is by using something called a Security Information and Events Management Appliance. So some of these, they're called SIEMs, SIEM. Some of these are like Splunk, ArcSight, these are common ones, but the idea is that you can aggregate all of your logs from your Exchange servers, your web servers, your gateways, your Active Directory logs, your Windows event logs into one place, and you can look for trends. You can correlate data and see if there's an attack that's evident on the network. So that's all I have today for SYN Floods. Go ahead and leave a comment if you thought this was pretty interesting. Make sure you thumb it up and hit that subscribe button because I love subscribes. And I will see you tomorrow morning at 8 a.m. Eastern, 7 a.m. Central, where we're going to talk about secure router configuration and ACLs. ACLs. I love saying ACK and ACLs, ACLs. So I will see you then. In the meantime, I'll talk to you later. I'll see you tomorrow morning.